Hi, welcome to the Strategy in Focus. We're going to focus on fourth grade multi-digit division and specifically look at representing strategies and explaining how each part of the context of a problem is mapped on or included in a representation. So let's consider this task. There are 240 children in fourth grade. If the teachers need to put them into groups of 14 for field day, how many groups will there be? Part 2 talks about any remaining students will be added to a group, so some groups will have 15 students. How many groups will have 15 students? What is the equation that matches this task? So, as we know, we're taking 240 and we are sharing them or dividing them equally into groups of 14 students each. So, one strategy is to use the idea of multiplication and to list the multiples out in a multiple tower. As you can see here on the screen, we're listing the multiples of 14. We make a clean break at 14 times 10 to help students organize that. At 14 times 10 equals 140. And as you can see on the right-hand column, I'm going to keep adding multiples of 14 up until I get to 238. I know, as it says in the yellow box on the right, if I add another group of 14, I've gone over 240, and I only have 240 students, so I know I need to stop at 238. One of the things to think about with students is the idea of where is the 240 in the problem and where is the 14 represented. Another idea is to think about a multiple tower, but instead of listing every multiple, starting with a friendly multiple. For fourth grade students, that would be multiples of 2, 5, 10, and in some cases 20, 50, and 100 when working with four-digit numbers when we're dividing. In this case, 14 times 10 is a really good starting multiple to get me to 140. As you can see, the left side shows the addition of numbers up to 240, and the right side really shows this idea of a keeping track, or almost like a tally sheet, if you will. So as I think about 14 times 10 is 140, I know that I'm nowhere near 240 at this point. So I know that I can also include 14 times 5, which is 70. So over on the right side, that gives me a total of 210, which, as we can see here, is 30 away from my target of 240. The student then, as we see over here on the left side, decides to account for the 30 with one group of 14, which then leaves them with 16, and then another group of 14, which then leaves them with a remainder of 2. We know that 2 is smaller than 14, therefore there's 2 students that are remaining, so 2 teams or 2 groups will end up with 15 students. The last strategy to think about is this idea of an open array. The 240 is going to be represented by the value of the numbers inside of the array, and as we can see, the 14 is represented by this dimension over here on the left side. It works very, very similarly to the idea of multiple towers with friendly multiples, where a student would think about a friendly multiple. 14 times 10 is 140, and that would end up being the start multiple. And down here at the bottom, we know that that gets me 100 away from my total. As we move over to the right, 14 times 5 being 70. So if I keep track of the distance from 240, I'm at 100. When I take away 70, I'm at 30. And then that 30, just like we saw in the earlier representation with multiple towers, gets accounted for with a 14 and 14 more, which then leaves me with a remainder of 2, which I'm showing with these 2 blocks right here. When we think about that in terms of the answer in terms of the number of groups or teams would be the sum of these numbers up at the top. The 10 plus the 5 gets me 15, plus 1 more gets me 16, plus 1 more gets me 17, and then that remainder of 2 means that I would have 2 teams with an extra or a 15th student. The standard that we've been working with is here for you. Just to point out, we've been working with strategies based on place value. There's also been a lot of work with this idea of the relationship between multiplication and division. One of the things to instill in students as you work through these tasks is where the numbers from the equation actually appear in the representation.